All right, I welcome us into today's class, studying indices, questions on indices. My name is Matthew Okafor, also known as Calculus. All right before us, we are faced with two problems. First one says 4 raised to power x plus 2 plus 5 bracket 4x equal to 336. That's 336. Number 2, 5 raised to power 2x plus 1 minus 6 bracket 5x bracket close plus 1 equal to 0. So solution, we're going to pick the first one first, which is 4x plus 2 plus 5 4 raised to power x equal to 336. All right, what are we going to do? We are going to separate this, okay? We're going to separate it. Remember, in indices, if you have m raised to power n, all right, times m raised to power a, our answer becomes, to pick the base, becomes n plus a. All right. Remember this. So we apply this here. We now have, if we apply this, this is something like this. Bring it back. All right. So we now have 4 raised to power x times 4 raised to power 2. They are the same. Plus 5 bracket 4 raised to power x equal to 336. All right. Okay. So 4 raised to power x times 4 raised to power 2. 4 raised to power 2 is 16. So we have 16 times 4 raised to power x plus 5 bracket 4 raised to power x is 5 times 4 raised to power x. So we have 5 times 4 raised to power x equal to 336. All right. Now, 4 is this becomes 16 4 raised to power x plus 5 4 raised to power x. Do you understand? 16 4 raised to power x plus 5 4 raised to power x. Assuming 4 raised to power x is unknown. So you add these two, you add it, okay? Then we give you 21. Then 4 raised to power x, 4 raised to power x is common. So we can pick 4 raised to power x equal to 336. All right? So at this point, we are now going to divide by 21 so that we can have 4 raised to power x alone. This go, we have 4 raised to power x. Okay? Now, 336 divided 21, we have 16. Now, this 16 means 4 raised to power 2. So if we compare this and this, we can strike the base out. They are the same. Therefore, x is equal to 2. You see that? X is equal to 2. All right. Now, having done that, we can now go back to number 2. Number 2, which is this, and then solve for number 2. Remember what we did in the previous example? You can separate this using the law of indices. The law of indices. You can separate it using the law of indices. So doing that, we have 5 raised to power 2x times 5 raised to power 1. You get? Then minus 6 raised to bracket what? 5 raised to power x plus 1 equal to 0. All right? Equal to 0. Remember, this 5 raised to power 2x can still be 5 raised to power x, or bracket square, times 5 raised to power 1 minus 6 bracket 5 raised to power x plus 1 equal to 0. All right? Okay, now let's assume, let 5 raised to the power s be equal to y, so that we can remove it there and substitute it for y. So this means that y squared times 5 raised to the power 1 minus 6 bracket y for this plus 1 equal to 0. Okay? Evaluating, you now have 5y squared minus 6y plus 1 equal to 0. This now looks like a quadratic equation. Getting the factor, okay, we say 5 times 1 is 5. Then we now have to look for numbers that when you multiply them together, you get plus 5. When you add them together, you get minus 6. And those numbers are what? Minus 5 and minus 1. These are the factors. Because minus 5 times minus 1, look at it, minus 5 times minus 1 will give us plus 5, which is what we get here, this by this. Then minus 5 minus 1 will give us minus 6. So minus 1 and minus 5 are factors. Having known the factors, we proceed. All right? We proceed. So we now have that 5y squared minus y minus 5y plus 1 equal to 0. Having known the factors. So now we factorize here, putting the bracket here. Okay? So what is common here? Y. Bring out y. What is remaining? 5y minus 1. What is common here? Minus 1. We have 5y minus 1 equal to 0. If you use y to open this bracket, you get this. If you use minus 1 to open this bracket, you get this. So this gives us y minus 1, this and this, bracket 5y minus 1 equal to 0. So this is now y minus 1 equal to 0, or 5y minus 1 equal to 0. So when this crossover here becomes y equal to 1, or when this crossover here, we have 5y equal to 1. Y equal to 1, or dividing by 5, we have that y equal to 1 over 5. So therefore, y is equal to 1, or y is equal to 1 over 5. All right. Having seen that y is equal to 1 or y equal to minus 5, let's remember that we made an assumption. We made an assumption that let what? 5x equal to y. So it means that anywhere we see y, we substitute it at 5 raised to the power x. 5 raised to the power x. So going back to this, that we have that y equals to 1 or y equals to 1 over 5, it means that since y is equal to 1 or y equal to 1 over 5, and we remember that 5x is equal to y. 5x is equal to y. So what that means is that we now say 5x equal to 1, or 5 raised to the power x, equal to 1 over 5. Okay? We are looking for x, not y. We are looking for x, not y. So what this means is that we now say, remember that anything raised to the power 0 is 1 in indices. So 5 raised to the power x equal to 5 raised to the power 0 is the same thing, because 5 raised to the power 0 is still 1. Okay? Or 5 raised to the power x equal to, remember, we say anything raised to, when we have 1 over anything, it means that thing raised to the power minus 1. So we have 5 raised to the power minus 1. All right. So now equating the bases, this and this, and this and this, equating the base. So we now say that x is equal to 0 or x equal to -1. So this is our solution. All right.